Here we go then. Today's video is all about, would help if I had a pen. Here we go then. Today's video is all about surds. Everyone loves a good surd, but for some reason people are scared of these things. Now it's a weird made up word, and all a surd is just a square root that we can't easily work out. So for example, root 9, square root of 9, we know that that's just 3, don't we? So that is not a surd because we can work it out. On the other hand, something like the square root of 2, well, we can't work it out. It carries on forever. It's 1.7, 1.4, 1 something or other. And it carries on forever, so that is a surd, and we can't do anything with it without a calculator. We can't simplify it anymore. There's nothing else we do, we don't get a nice number. Now, at this point, it would help if we knew all the numbers that you can easily square root. And those are your square numbers. So 1, square root of 1 is 1. Square root of 4, that's 2. Square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 81, square root of 64 is 8, square root of 81 is 9, and of course the square root of 100 is 10. Now these numbers, these are the square numbers, and you can easily square root them. Your square numbers, or the squares, and they're going to be really useful when it comes to simplifying surds, which is the first thing we need to do. Now, for example, if you want to simplify something like root 45, now it's not in the list, so we can't just simplify it straight away, but what we can do is we can break it down into two numbers that times together to give you 45. Now, can you think of two numbers that times together to give you 45? And one of them has to be in this list here. If it's not in that list, it's no use to us. Now, 45 obviously is 9 times 5, isn't it? So the square root of 45 is the square root of 9 times 5. You can split that up into the square root of 9 times by the square root of 5. Now, square root of 5 you can't do anything with, it's not in the list. But the square root of 9, we know we can replace that by 3, don't we? So that's just 3 times the square root of 5, which we just write as 3 root 5. That's that one simplified. And the whole meaning of simplify is basically make the rooty bit inside the square root as small as you possibly can. Okay, let's do one more. I'm going to simplify this time root 50. Have I gone from blue to black pen? Who knows? Now, 50 we know is 5 times 10, but they're not in the list. We also know it's 25 times 2. So we can split the root 50 into root 25, root 2. And then, of course, we know that the square root of 25 is just 5. So that can become 5 root 2. So we've simplified root 50 into just 5 root 2. Now the whole point really of doing that is to let you add and subtract surds. So it's a little bit like adding fractions, where you can only add fractions if you've got the same denominator. Same deal with surds. You can only add surds if the same rooty bit is the same root. And if they have the same root, you just add them together. So if you've got 3 lots of root 2, and you add on to that 4 lots of root 2, all you're doing is counting up how many root 2s you've got. So you've got 3 of them, and you've got 4 of them. How many is that? It's 7 of them. And the root bit stays the same because you're just literally counting up how many root 2s you've got. You've got 3 root 2s and 4 root 2s, that is 7 root 2s. Now, that's fine because they have the same root bit. But if you don't have the same rooty bit, for example, root 50 plus root 32, okay, not the same rooty bit, can't just add them together. We have to simplify them first. Now, root 50, one that we did previously, isn't it? That can split into root 25, root 2. Root 32, we know that 32, let's put it off thing over here, 32 we know is 16 times 2, don't we? So we can split this into root 16, root 2. Now, root 25 we can do, root 16 we can do. They're nice numbers, so that's just 5 lots of root 2. And that one there is 4 lots of root 2. How many root 2s have we got? We've got 5 of them, and we've got 4 of them, 5 of them, and 4 of them. That's going to give us 9 of them, isn't it? 9 of those. There it is, simplified. So root 50 plus root 32 simplifies down to 9 root 2. Now, subtraction, exactly the same, apart from, instead of adding in the middle here, you're going to subtract. So if that was a minus sign, that was a minus sign, that would be a minus sign, that would be a minus sign. You do 5 root 2, take away 4 root 2, you just get 1 lot of root 2. Now, sometimes in an exam situation, they like to confuse you slightly by writing things, the questions, in slightly different ways. Now, here's a really typical way of writing a question, and I just highlighted the key bits there. So we're starting with root 45, and what they want us to do is write it in the form of k root 5, and this bit here says k is an integer, so k is just a whole number. So we need to write this in the form of something times root 5. Now that's just another way of saying simplify root 45 and end up with an answer which is something root 5. Okay, so we're going to simplify root 45, and we know that 45 is 9 times 5, don't we? And if you can't immediately recognise that, there's a bit of a clue in that you have to end up with a root 5 there. So that's going to become, separating them out, root 9 times root 5. We know what root 9 is, it's just boring over 3, and that is 3 root 5. So we've written the root 45 in the form of something times root 5. What's the something? It's a 3, so k there is 3. So it's just another way of saying simplify root 45. Nothing more complicated than that. Now, before we do this next question, we need to talk about multiplying and dividing. So, multiplying surds, if I can write multiplying, yep. Multiplying surds, it's quite easy. So you've got 2 options, depending on really how complicated things are, but you can just think of this. Imagine if you were just doing that one. If you want, you can just multiply what's inside the square roots. And that's the square root of 3 times 12. And you know that 3 times 12 is 36. And you know the square root of 36 is 6. That's one way. Now the alternative way, which you sometimes need, it's very wobbly, is that you simplify things first. So the root 12, I'm going to simplify. Now, root 12 is root 4 times root 3, because we know that 12 is 4 times 3. So we've got root 3 there. We know that root 4 is just 2. So that's 2 times root 3. So what we've got is 2 times root 3 times root 3. And we know that root 3 times root 3 is root 9, which is 3. So that's just 2 times 3, which is, of course, 6. Okay, so you can either multiply everything first in the square roots, or simplify, then multiply. Quite straightforward. What's a bit more tricky is dividing. Now, dividing by a surd would be something like this. Root 45 divided by root 5. Now, the way to do your dividing is to think of it as being a fraction. So root 45 divided by root 5. And what we're going to do is make an equivalent fraction of that by simply multiplying the top and the bottom by something. And the something we're going to choose is a root 5 over root 5. Okay? Multiply the top and the bottom by something. Doesn't change the value of the thing you start with. Now, root 45 times 5, I'm going to simplify the root 45 first to make the multiplying a bit easier. That's root 9 root 5 over root 5 times by, there's lots of roots here, root 5 over root 5. We know that root 9 is just 3, don't we? So this, continuing up here somewhere, is just 3 root 5 over root 5 times root 5 over root 5. Again, lots of roots. Now the top, 3 times root 5 times root 5, that's just 3 times 5, because root 5 times root 5 is 5. On the bottom, root 5 times root 5 is 5. 3 times 5 is 15, divide that by 5, you get 3. Now, this process of dividing is also known as rationalising the denominator. Rationalising the denominator. And what that means is, rationalising means changing it into something that's not a surd. So the denominator here in this fraction was a surd, still a surd. Here at the end though, not a surd. So we fixed it, we've made it not be a surd at the bottom. And that's the way you do dividing of surds. It does get a little bit more complicated, as we'll see in a minute. Now, here's a fairly typical exam question which involves all of the above. We've got root 18 plus 10 all divided by root 2. And we're going to first of all simplify the root 18. We're going to change that into root 9 root 2, because 9 times 2 is 18, plus 10 all divided by root 2. Now the root 9 just becomes 3, and that's 3 root 2 plus 10 all over root 2. Then, to deal with the root 2 at the bottom, we need to rationalise the denominator. I'm just going to put the top in brackets to make that really obvious what we're doing. Over root 2, and we're going to times by, because there's a root 2 at the bottom, we're going to times the top and the bottom by root 2. And on the top, we have to times everything in that bracket by the root 2, which is why I put it in brackets. If we carry on up here, we're going to do the root 2 times 3 root 2. That's just 3 root 2 times another root 2 plus the 10 times the root 2. That's the top done. And all of that is divided by root 2 times root 2. Time for tidying up. Now, on the top, we've got 3 times root 2 times root 2. And we know that root 2 times root 2 is just 2, so you've got 3 times 2 there, which is 6, plus 10 root 2. And on the bottom, the denominator, you've got root 2 times root 2, which is, of course, just 2. So we need to then divide the whole numerator by 2, so we get 3 plus 5 lots of root 2. There we are, can't simplify it anymore. We've got to that point there, and that is in the form of p plus q root 2, where p is 3 and q is 5, so q root 2 is 5 root 2. It's an awful lot of stuff going on there. There's rationalising, there's expanding a bracket, but take it step by step. It does make sense. Now we get to this beast, which is probably as bad as they're going to get. So we have to simplify all of this. Now the top, the numerator, is a bracket times a bracket, isn't it? We do a bracket times a bracket using FOIL. So the first thing times the first thing. So the 5 times the 5, that's 25. We'll do each one in a different colour. The O of FOIL stands for the outside thing, so the 5 times the minus root 3. 5 times minus root 3 is minus 5 lots of root 3. The I of FOIL stands for the inside things, so things in the middle here. So the root 3 times the 5. That's going to be plus 5 lots of root 3. And the L stands for the last thing in this bracket times the last thing in that bracket, which is root 3 times root 3, which is of course 3, but because it's a plus times a minus, that's minus 3, isn't it? All divided by root 22. We've still got a surd at the bottom. We'll deal with that in a minute. Now, just to tidy up on the top, we've got 25 and minus 3, that's 22. And then these two bits, we've got a plus 5 lots of root 3, take away 5 lots of root 3, that gives you nothing. So all we've got on the top of that horrible looking fraction there is just 22. And then it's all over root 22. Now, because it's a surd at the bottom, we don't like that. It's got to be in its simplest form, and that means no surds on the denominators. We're going to rationalise it by multiplying the top and the bottom by root 22. So on the top, we've got 22 times root 22. And on the bottom, we've got root 22 times root 22. Carry on up here. The top we can't do much with. 22 lots of root 22. Bottom, root 22 times root 22 is of course just 22. So we've got 22 of those divided by 22, that just leaves you the root 22. There it is, fully simplified. Now, there are trickier rationalising denominator questions where you've got more than just a simple square root down the bottom here. So if you had something like 3 plus root 2 at the bottom, that's a whole new situation And we'll come back to that in a separate video. So hopefully we've given you a good overview there of surds. Simplifying just by breaking them into one of the easy numbers to square root. Adding and subtracting by simplifying to get the same square root and then just adding and subtracting. Simplifying in the exam question type wording. Multiplying, either multiply them directly or simplify and then multiply. Dividing by a surd, think of it as a fraction, and then times the top and the bottom by whatever's at the bottom there. And that makes the bottom come out nice. Slightly trickier exam style question. Simplify to get the top simplified, and then because you've got a root 2 at the bottom here, multiply by root 2 over root 2. Do some sorting out, a bit of tidying up, there we go. And then a trickier one where we had to do some multiplying double brackets at the top, which gave us a surd on the top and a surd on the bottom. We rationalised it to get to that situation and it simplified nice. That's a quick overview of adding, subtracting, multiplying, dividing surds and rationalising simple denominators. We'll do the more complicated ones in a separate video. Hopefully that's giving you a really good start on some surds questions in a non-calculator paper. If you'd like any other topics covered, comment on any of these videos and we will produce a video on whichever topic you want. If you have a particular exam question in mind, let me know which exam board, which paper, which question, and I'll solve it for you in a future video. Hope that helps. Please like this video. If it's been useful, please subscribe to the channel to get notified of future updates. Happy maths!